Welcome again to our next lesson on differentiation. Alright, we are going to look at how we differentiate a function by the first principles, Okay, and we know that as we have learned of differentiating of a normal function. Okay, so let's remind ourselves, or let's revise. When we are given, let's say y is equal to 6x squared plus 2x, you know our dy over dx will be what? 2 will multiply by 6. Alright, that will give us 12. Okay, then we subtract 1 from the exponent of the x, so 2 minus 1 will give me 1, so 12x exponent 1 is the same as 12x plus, then here is also 1 times the 2 give me 2, so when I take 1 from it, then become x exponent 0, which is 1, so it becomes what? It becomes 2. So our differentiation of 6x squared plus 2 will become what? 12x plus 2. Okay, so now we are going to learn how we can use what? The first principle to also differentiate. Okay, from the first principle, our differentiating is what? Dy on the s, or we can say f prime of what? X, which is equal to the limit as h approaches 0, and then you have what? F of s plus h minus f of x all divided by h. So this is our first principle. Okay, the limit as h approaches 0, f of s plus h minus f of x all divided by h. So it means that when you are given the function, then what you are supposed to do is what? Is to substitute the function. Okay, so wherever you see the function, in the first we have f of s plus h. So wherever I see x or whatever variable is used in the function, I'll substitute s plus h. And then wherever, here is also what? You write the main function. Okay, so if the function, for instance, for example, x. So I'm going to use the first principle to differentiate 8x. Okay, it means that my f of x, the function is what? Is the 8s. Okay, so my function here is the 8s. And then if I want to find my f of x plus h, it means that the function which is 8s, wherever I see x, what do I substitute there? X plus h. Okay, because we have the f of s as 8x. Okay, so wherever I also see s plus h, the function 8s, I'm going to substitute what? Wherever I see x, I'll substitute s plus h. So f of s plus h can be written as what? 8 into brackets s plus what? S plus h. Okay, but wherever s is, I'll substitute s plus what? S plus h. Alright, and then if I look at the first principle, see here, this is the formula for the first principle. We said that f of s plus minus f of all divided by what? H, as h approaches was 0. And you see that the h here is what? The h here is a denominator. So if h is approaching 0 and the h here is a denominator, then what happens that if I substitute 0 here, it will make the whole function to be what? To be undefined. So what you should make sure that don't let the denominator to be what? To be 0. Okay, so that is one thing you have to take note, that the denominator shouldn't be 0. Alright, so that when the denominator is, we have learned about limits. Okay, when the denominator is not 0, then we can find the differentiation of what? Of the function. Alright, so let's go straight. Okay, and then we are going to solve this particular question here. Okay, so let's solve the example. Differentiate from first principles. Okay, so differentiate from the first principle, y is equal to 8s. Okay, so from the first principle, we know that what? Our solution, our dy on the x, okay, which is the same as f prime of x, can be what? The limit as h approaches 0, f of x plus h minus f of x, okay, all divided by h. So we are going to differentiate this, okay, from the first principle. But before that, We know that if I have y is equal to 8x, what is the differentiating of this? The normal differentiation. dy dx will give us what? Which will give us 8. So it means that after we have solved this particular question here, our answer should be what? Our answer should be 8. Okay, and we have learned on this, so I know you know the reason why it is 8. Okay, so when you get a question, you are going to use the first principle. Use the normal, the simple of what? Differentiation. And then you write your answer sample, so that when you are solving the question, you know that you are going to what? You are going to get the same answer. Alright, so let's continue. So we have the limits as h approaches 0. So we are going to differentiate y is equal to at 8s. Okay, so in the first, we have the limit as h approaches f into bracket s plus h. Okay, it means that with the function y is equal to 8s, wherever we see s, what do you substitute there? S plus h. So that can be written as 8 of s plus h minus f of s. What is the f of s? F of s is this particular function here, 8s. Alright, all divided by h. So this is what we are going to have. Okay, so this y is equal to 8s is the function of f of x. Okay, so we have f of s plus h. So you substitute wherever you see s, you put s plus h there, minus f of s, which is the main function, all divided by the h. Alright, so what we are going to do, the h approaches 0. Okay, so when you put 0 here, what it means that you are going to get the whole thing to be undefined. So make sure you expand, and then you, after your expansion, then you continue and see if you can cancel out common factors so that you don't get the function to be undefined. Alright, we have our limit as h approaches 0. So 8 times x will give us 8s. 8 times h will give us 8h minus 8s, all divided by h. Alright, so what this means is that 8s is over h, 8h is over h, and then the 8s here is also what? Over h. Alright, but so we have 8s minus 8s, which will give us what? 0. So our limit as h approaches 0, we will have 8s minus 8s will be 0, so we have 8h over h. And what is 8h over h? 8h over h will give us, h will cancel h, and it will give us h. So our limit as h approaches 0, since we don't have any h value here, then it will become what? The constant 8. So we have our answer as what? As our answer as 8. So when you differentiate this particular function, y is equal to 8s, your answer will give you 8. Alright, we are going to solve the next question. So Maxwell, I believe you have missed Maxwell. Those of us who have followed our videos for some time, you see, we watched some of the videos, and then Maxwell taught us very well. So Maxwell will come and then also solve the next question for us. He's also a student like you, so as he solves the question, you also look at it and also learn from there. All right.
Good day, lovely people. Let's consider this question from differentiation from the first principle. And the question says, differentiate from first principle y is equal to x squared. And y is equal to x squared can be written as f of x is equal to x squared, where y is equal to our f of x. So now we can differentiate it in our normal way of understanding it. So you can say dy dx is equal to 2x exponent 2 minus 1. So therefore dy dx is equal to 2x. So by differentiating it in our normal way of differentiation, our dy dx will be 2x. So now the question demands us to differentiate from the first principle. So we will state the formula for the first principle and then move on. So the formula for the first principle is dy dx is equal to, or f prime of x is equal to limit as h approaches 0, bracket open, f of x plus h minus our f of x, all on h. So here is the formula for the first principle. So here we find our f of x plus h. So therefore our f of x plus h is equal to x plus h all squared. This means wherever you find your x, you substitute it by x plus h. So now we need to expand this expression over here. So we can say, we can go on or move on by expanding it by doing it this way. So therefore our x plus h squared. So we can say x squared plus 2 multiplied by x multiplied by h, 2xh, then plus h squared. Or we can do it this way, x plus h. X plus h. Okay, so x times x is x squared, x times h is xh, and then h times x, or x times h is xh, and h times h is h squared. So here you can say x squared plus 2xh, that's, and then h squared. So the same way of solving it. So now we've gotten, or we've expanded x, the fraction f of x plus h. So we move on. So now our f of x, we know our f of x to be x squared. So now dy dx is equal to limit as h approaches 0, bracket open, and our f of x is known to be x squared plus 2xh plus h squared minus our f of x, and that's x squared, all on h. So here we now express this expression over here by cancelling our x squared minus the x squared, and that will give us 0. So x squared minus the x squared cancels itself. So now our dy dx is equal to limit as h approaches 0, and we have 2xh on h plus our h squared on h. So now we do cancel them, the like terms over here. So h cancel h, and then h cancel here 1, and cancel here the 2, remaining 1. So 1h remaining here. So we can now say dy dx as limit of h approaches 0, can now say 2x plus h, and as and as h approaches 0, we then substitute 0 into wherever we find our h. So limit h approaches 0 is equal to 2x plus h now. So now wherever we find our h, we substitute it by 0. So now we can say 2x plus 0. So we can say by substituting, we can say the final answer is 2x. So from here we can see that the final answer is 2x. So thank you very much, my lovely people. See you again, and bye bye.